In today's lecture, we are going to learn what is theta notation. So, how it is beneficial in respect of identifying the complexity of an algorithm. So, let's understand. Suppose this is a graph. This is a graph, and we have something like that. And this is n naught. As we have seen last two lectures, what is n naught? In the similar way it is here and here. This is C1gn, this is C2gn, and this is Fn. And this is Fn. So, and here it is Fn and gn. So, yeah. So, what is that? When it will be theta, when it is in between. It is in between upper bound and lower bound. So we can say like this, that function is equal to theta gn when fn is less than equal to c1 gn and fn is greater than equal to c2 gn. For all n, and n is greater than equal to n naught, where n naught is greater than 0, right? So here again C1 and C2, C2 and n naught all are positive constant. So it is in between upper bound and lower bound. So we can say when best case and worst case. When best case and worst case both are same, then we can say it is a theta notation, and it is considered as a theta notation. So let's take an example, or we can say, let's take an example. Suppose, as I have written the function definition here, so suppose if fn is equal to 3n plus 2 and gn is equal to n, so how we will satisfy the condition? So you are able to see in fn is less than cgn and fn is greater than c2gn, right? So how we can write c1n less than equal to 3n plus 2 and less than equal to c2n, or you can write opposite, right? Here you can write c1, here you can write c2, no problem. c2 c1. So c1 is less than fn and c2 is greater than fn, right? So we can write like this also. Now we need to find out c1, c2 and n value, because all are constant and not value. And not is the value. After that, before that it can be up and down anything, but after that value fn will always remain between c1 and c2. So need to figure out. Suppose if I am taking c is equal to 1, c1 is equal to 1, n is equal to 1, and c2 is equal to 4. Suppose I am taking like this, or c1 is equal to, not c1, this is c2 is equal to 1 and c1 is equal to 4. So what is the value here? We'll see here. N value is 1, c2 value is 1. So I am writing here 1, both are 1, right? N value is 1 right here, so 3 plus 2, and c1 value is 4 into 1. Right, 4 into 1 if I am taking. Suppose you can start from 1 also, no problem. I am supposing it here 4. So 1 is less than 5, but 4 is not true here. Not true. So we will take another value. Suppose if I am taking c1 is equal to, because for c2 it is okay, for n naught is okay, and but for c1 it is not okay. So suppose if I am taking c1 is equal to 5. So what it will be? So here it is same, c2 is same, no problem, right? 1, n value also I am taking 1, right? So here again it will be 5, but here it will be what? 5. c1 value I have taken 5, so 5 into 1, 5. So it is satisfying the condition, equal to condition. Suppose if I am taking now next n value, c1 will remain same, c1 is fixed 5, c2 is fixed 1. Now if I am taking n value as 2, then what it will be? c2 value 1 into n, 2, right? Here 6 plus 2, 8, right? Here its value is 5. 5 into 2, 10. So it is satisfying the condition, right? So if I am taking n is equal to 3 now, so what it will be value? So here n, right? So its value will be 3. Here 11, and here it will be 3. 5 into 3, 15. So we are able to see that it is satisfying all the condition. It holds true for all the condition. So we are able to see here, and we can say here that C1 value will be 5, C2 value will be 1, and N naught value is 1 here. So after that, this condition holds true for all the condition. This condition holds true for all the condition. So we can say here simply n square is equal to big O n square, and n square is equal to big omega n square. So we can say here this is the condition for tightest upper bound, and this is the condition for tightest lower bound. And when it is satisfying both the condition, as we are able to see, when it is satisfying both the condition, then we can say n square is equal to theta n square. Because as I have said, when both the cases are equal, right? When both the cases are equal, then it is theta. So yeah, we are able to see it is satisfying all the condition, and Fn is less than C1 Gn and Fn is greater than C2 Gn, as we have written over here. So this is all about the theta notation when function comes between upper bound and lower bound, and both worst and best cases are equal, are same. So tightest upper bound and tightest lower bound both are equal to, then we can say it is satisfying the theta condition. So this is all about the theta notation. If you like it, share it, subscribe it. Thank you.